Okay, so that first video was congruence. The second video is over similarity, similar figures. You should have turned in the worksheet from the sub. So once you're done with this video, you're going to have a book assignment. That assignment will be homework if you don't finish it in class. That's due Wednesday. So similar figures, if you remember, are the same shape, they're just a different size. So when we're talking about transformations, dilation is the only transformation that makes a polygon similar and not congruent. Okay, so same thing, our sides, our matchup, our angles are still equal. Okay, notice they have that congruent. But now, the side obviously are not the same, but if we write them as a ratio, as a fraction, the fractions, the ratios are all equal. And notice when they're similar, we just have the little squiggle. We don't have the equal sign with the squiggle. And I don't know the technical term for whatever that symbol is. So we'll call it a squiggle. Okay, so it says determine if these two triangles are similar using transformations. So if we're talking about transformations, it looks like we just dilated it. So dilation and a translation because we shrunk it down or we blew it up. Okay, if we're going from EDF to HGI, we blew it up and we slid it over. So we had a dilation and a translation. But we need to prove if they're similar. So to do that, I'm going to start by looking at side D to E. So this, if you know, there's 1, 2, 3, 4 boxes over, and then G to H is 1, 2, 3, 4, 5, 6, 7, 8. So 4 over 8. And if I would have done it the other way, I could have gone this way, had 8 over 4. That's fine. I just have to be consistent. So that's going to reduce to 1/2. Okay. So then if I look from DF, that's 1, 2, 3 boxes. And GI is 1, 2, 3, 4, 5, 6 boxes. Well, that also reduces to 1/2. Okay, we could do Pythagorean theorem and figure, well, this is going to be a 3, 4, 5. Well, then this would be a 6, 8, 10, which 5 and 10 reduce to 1/2. So these are similar. And if we wanted to write it out, we could have triangle EDF is similar to HGI. And we put our symbols in there that we need. So I have triangle EDF is similar to triangle HGI. That's a terrible little squiggly there. Pretend that looks nice. Draw yours nicer than mine. Okay, so that's what we're doing. You see what the transformations are and then prove it's similar by reducing your fractions. Okay, looking at one more. So this looks like this was a dilation also. But it's also, oops, it looks like this one was a reflection. This one may have also been translated, so if you wanted to add a translation on there, you could. Okay, H to K is 1, 2, 3. And then E to G is 1, 2, 3, 4. That doesn't reduce. Okay, so K to J is 1, 2, 3, 4. And then F to G is 1, 2, 3, 4, 5, 6. Okay, well 4, 6 does not reduce to 3/4, it reduces to 2/3. So we don't even have to figure out the last one because these are not similar. 3/4 does not equal 2/3. So you're going to try this now on page 539 of your textbook. If you need to pause the video and then do your work and then come back and we'll look at the answer. Alright, so hopefully you had some time to work. Okay, so page 539, triangle UTS and RQP are similar. It was a dilation, and if you reduce your fraction, it looks like this one was double the size. So it had a scale factor of 2, so your fraction should have all come out to be 2. Okay. B was not. This is not similar because 3/2 is not equal to 5/4. So that's what you're doing there. Alright, so these problems are basically just multiplication, but you have to pay attention because you're going to have to do it twice. So Ken enlarges a photo by a scale factor of 2 for his web page. He then enlarges that photo by 1.5. So the original photo is 2 by 3. Oops, that's not what we want. So if we have this photo here that is 2 inches by 3 inches, well, we're going to make that bigger, which means we're going to double it first. Okay, so the first one we doubled. So the first time we enlarge it, it goes from a 2 by 3 to a 4 inch by 6 inch. Okay, so that's after the first enlargement. Okay, then we're going to enlarge it 1.5 times. Okay, so I'm going to multiply 4 times 1.5 and 6 times 1.5. So our final answer then, so 4 times 1.5, and you can use a calculator, is 6 inches by, and I want to say this is 9, but I'll double check, it's 9 inches. Okay, so that's our second enlargement, and that's our final answer, is the second one. Okay, so that's all you're doing, is multiplying them out. Okay, so a baker, and I apologize for the picture, I did it to be humorous, but a baker is reducing an 8 inch by 10 inch photo to put on a cake. He reduces it by a factor of 0.8. Okay, so you're going to multiply by 0.8. Then he decides that that is still too big, so he reduces that new one by 0.9. So the first one, I'm going to take my 8 by 10 times 0.8, so 8 times 0.8 is 6.4 inches by 10 times 0.8 is 8 inches, but that's still too big, so now we have to take those numbers times 0.9. So 6.4 times 0.9 is 5.76 inches by 8 times 0.9 is 7.2 inches, and that's our final answer, the second one here. So you don't have to show me both of them if you want to do this part in your head or on a calculator and then just do the second part, that's fine. Okay, so is it reduced? Is the reduced similar? Yes, because it was a dilation and we use the same scale factor for the whole thing. Okay, so I want you to try the got it on page 540. Okay, so on 540, hopefully you got 108 by 135. It is similar because you're using the same scale factor for the painting. Alright, so your homework tonight is page 541, 1 through 6, 8 and 10. Thanks for watching my first YouTube videos, and I hope you guys had a great spring break.